Hello. So today we are going to look at solving definite integrals or indefinite integrals by hand using polynomial long division and a few other tricks. So we're going to look at rational functions. And again, you have to keep in mind that ideally you want to recognize when to use this technique. I'm assuming that you know how to do polynomial long division and synthetic division. If not, then you should watch that video that I have linked as well. Okay, so we're going to do integrating rational functions of the form p of x over q of x dx. And the degree of p of x is greater than or equal to the degree of q of x. All right, so when the bottom is bigger degree, then we're going to use other things. But if the degrees are the same, or the degree of the top is bigger than the degree of the bottom, so you have x to the fifth on top, x squared on bottom, something like that, then you can use this technique. All right, so we're going to take a look at this right here. All the things we know so far about how to find integrals don't apply. It's not a W substitution. It's not really an integration by parts. Isn't going to work. So what we're going to do is we are going to turn this into something else that we know how to find antiderivatives for by actually doing the dividing. If you remember, this on the bottom has a 0 at -3, and so we can do this synthetically because it's x plus 3. If it was quadratic on the bottom, we could not use synthetic division, but here we can. And then I need to use all my coefficients, making sure I don't miss any. So I have a 1, a 3, a -5, and a 1. And I bring down my 1, and then I multiply my -3 by 1, and I add to get 0. And then I multiply again to get 0. And I add to get -5, and -3 times -5 is 15, and I add to get 16. All right, so what we want to do now is rewrite this as its polynomial. This is my remainder. This is my constant. This is my x term. This is my x squared term. So this integral that I have up here, when I actually divide, turns into x squared. I have 0x minus 5, and then plus 16 over x plus 3. Right? That's what I get when I actually do the division. Now, hopefully, all these pieces are things you know how to find the antiderivative for. For example, antiderivative of x squared, 1/3 x cubed. Antiderivative for -5 is -5x. And this one right here, it's a little dub sub, but hopefully it's a dub sub you can do in your head. We have 16 over a function of x, and the derivative of the function on the bottom is just 1. So we are going to have plus 16 ln of the absolute value of x plus 3 plus c, because it's an indefinite integral. You always have to add your constant. And it should, if you do a quick check, derivative of 1/3 3x, or 1/3 x cubed is the 3 is going to cancel with the 1/3. I'm going to have an x squared. I'm going to have a -5. And the derivative of this, I'm going to have 1 over x plus 3 times the derivative of x plus 3, which is just 1, and then the 16. So we rewrote our longer integral by doing the dividing. Let's try another one. Again, my bottom is a linear. It has x to the 1 power, so I can use synthetic division again. And I do -1. And this is a little trick to my top because there isn't an x cubed term. So I have to assume the x cubed term coefficient was a 0, and then I'm going to have -7. There also is not an x term, so I need another 0, and I need a 10. I always bring down my 1, multiply my -1 up here by my 1, get -1, and then I add to get -1, multiply again to get 1, add to get -6. I'm going to multiply to get 6, add to get 6, multiply to get -6, and I add to get 4. Again, this is my remainder. This is the constant. This is the x term. This is the x squared term. This is the x cubed term. So the integral I had at the top can be rewritten as x cubed minus x squared minus 6x plus 6 plus 4 over x plus 1, because that's my remainder. All right, so now I'm going to find the antiderivative of this. I forget everything that came before. Now, these are all antiderivatives we should know. Again, antiderivative for x cubed is 1/4 x to the fourth. Antiderivative of x squared, 1/3 x cubed. Antiderivative for 6x is 3x squared. Antiderivative for 6 is 6x. And the antiderivative for 4 over x plus 1. I'm going to have my 4 out front, and then ln of absolute value of x plus 1, and we add a constant. Okay, so that's sort of the process. When the top power is bigger than the bottom power, you can divide. You can also divide, so I'm going to show you two methods to do this problem. You can do the division. This I can do synthetic. I have -7 into 1 and 0. And so I can bring down my 1. I get -7. I add, and I get -7. Again, that's my remainder. So my integral up top can be rewritten as 1 minus 7 over x plus 7. And then I find my antiderivative, which is x minus 7 ln of x plus 7 plus c. So that's method 1. There's another method for this that you can get away without doing the dividing, especially if you don't like the dividing. And this is a little math magic trick. So I'm going to actually copy this. And I'm going to... So this is a way to amaze your friends and coworkers. It's one of those things that some mathematician thought of, and it's a really neat trick to use. So we are going to say that my degrees are the same. The top looks very much like the bottom, and if I could add 7 to the top, that would look exactly like the bottom. But you cannot just willy-nilly add 7. That changes what something is. The two things we can do that change what something looks like but doesn't change what it is to multiply by 1 or add 0. So if I add 7 to the top and subtract 7 from the top, that top is the same. That is the same as x. The nice part about this is now I can rewrite this as two separate pieces. X plus 7 over x plus 7 minus 7 over x plus 7. If I had these two fractions down here, I could rewrite them as one fraction because they have common denominators, and I would have this right here. And again, if I have this right there, that's the same as this. Now we go right here, x plus 7 over x plus 7 is 1. Notice this is the same answer as what we had before. I just haven't had to do the dividing. And it might seem like more steps, but a lot of it you could sort of do in your head. You might be able to jump right from here up at the top to here by doing your plus 7 minus 7 and split your fractions. But notice that is the same thing, 1 minus 7 over x. If you want the antiderivative, there it is. It's going to be the same antiderivative when we do it from here. So that's a little trick. This trick shows up here again. Again, you could do the dividing. You could divide the bottom into the top. You could not do synthetic division because you have your x squared. So you'd have to actually x squared plus 0x plus 1 into your top, x squared plus 5x plus 1. I don't really want to do that. Part of me does because I really like doing polynomial long division, but I want to do something shorter. So here's my trick again. I can take this fraction and split it into two equivalent fractions. So I can say, oh, there's an x squared plus 1 and an x squared plus 1, and then there's a 5x over x squared plus 1. See, that's, I take this one fraction on top and I split it into two fractions, both with the same denominator. And again, this becomes 1 plus 5x over x squared plus 1. Now this part right here, I know this is going to take a little work, and hopefully you recognize that. What are our other methods of antiderivative? It's not one I know in my head. I think a little bit of arctan, but that's, I don't know how I'm going to get that 5x on top. So it really is a W substitution problem with, or U substitution, W sub x squared plus 1, because then dW is 2x dx, which is a multiple of that right there. So if you're good at doing them in your head, which hopefully by now you're getting better, right? I can just, so we're just going to jump to the antiderivative, and I'm going to do antiderivative of 1 is x antiderivative of 5x over x squared plus 1. Well, I want to do this ln of x squared plus 1. Okay, and I'm going to do a plus c. Now I have to sort of figure out my constant. If I take the derivative of ln of x squared plus 1, I'm going to get 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. That's really close to what I had, but I want a 5, and I don't want the 2. So to get the answer that I want, I need to multiply this by 5 halves, which means I need to insert 5 halves right there. And there's my answer. If you need to do the whole W substitution process, you can do that. I'm fine with that. Right? But you can hopefully at this point start to see, oh yeah, this is something 1 over something multiplied by 5, and then the derivative of that thing multiplied by a constant. Okay, so if you're at home, in class we did a little quiz, use partial fractions. So this is reviewing what we did yesterday in class. It would be a good idea for you to try this quiz, see if you get it. You could bring your try it without your notes, without anything. This is just for you, see what you can do. You could bring it to me to check when you get back.